In this short demonstration, I'll show you two examples on how to find the derivatives of inverse hyperbolic functions. The derivatives of inverse hyperbolic functions are shown below. We'll start with question number 1. In this question, they are asking us to find the inverse hyperbolic function of sine of x squared plus cosine x. So consider this your x, and we're going to use this pattern to find the derivative. 1 over the square root of 1 plus this thing, x squared plus cosine x to the power of 2. And what's not shown here is you have to find the derivative of that term. So our next goal is to find the derivative of this, and that's not hard to do. And whatever that derivative is, you will multiply it to this term. So the derivative of x squared is equal to 2x, and the derivative of cosine x is equal to negative sine x. Combining these two terms, since they are a product, you end up with 2x minus sine x over the square root of 1 plus x squared plus cosine x all squared. There's question number 1. Let's move on to question number 2. Question number 2 is slightly more challenging, and I have written some of the important things that you need to know in order to answer this. The first thing, obviously, you'll need to know is how to find the derivative of a logarithmic function. I do have a video dedicated to that, and what we took from that video is the following. So let's call this right here our x value. And what we will do is write our derivative, f prime. Our x value is shown right there, tangent h of 2 to the power of x. And we have ln of our a value, and in this case it's 6, that's your a value. And what's not shown in this pattern here is that you also need to find the derivative of that. So we have to find the derivative of tan h 2 to the power of x. Let's do that. First of all, let's make this smaller. Now the derivative of tan h, the hyperbolic function of tangent, is shown right here. So let's implement that. We'll multiply this by secant h squared. And in our case, this is your other x. So we're going to write that down right here. And at the same time, we're going to derive 2 to the power of x. And this is where this part comes in. Your a is your 2, your x is your x. And so what we'll do is multiply this growing expression by 2 to the power of x ln of your a value, which is 2, times the derivative of x, which is 1. Let's put this all together in a nice, neat way. The hyperbolic function of secant squared 2x times 2x times ln 2 all over the hyperbolic function of tangent 2 to the power of x times ln 6. And there you have it. Those are two examples on how to find the derivatives of inverse hyperbolic functions. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at biology-forums.com. We are an online service for students seeking free homework help. See you soon.